Alright, so first we need to graph all the constraints or all the lines on our graph. So let's consider that done. Let's go over a problem where they don't really meet in a great spot. So the whole process is graphing inequalities, we're going to shade the feasible region, and then we need to identify the vertices. That is the tricky part on this one. So what we're going to do is focus on that. There's the shaded region. There's one vertex, which is -2, 0. Easy to find because clearly when you continue the pattern here, right, when you plot those points and you plot this line, they all lined up and hit the same spot. So you know that that's a point on your line. But now when you continue the pattern here, we have a point there, there, and there. Clearly you don't ever shade the same points. So we need to find where that point is. So how are we going to do that? All right, it doesn't meet right on the grid. There are many of ways we've done this already, right? Where two lines meet is really the solution to a system of equations. So how many different ways have we solved systems of equations? There's a bunch of ways. One is by graphing, so we could just go to your graphing calculator and plug them in and calculate the intersection. You got to get y = form for both of those. Use the substitution method. You can use the elimination method if you want to do it by hand. We have a couple ways to do it with matrices. You do the A inverse X using inverse matrices, or my favorite, the RREF. That's the easiest to do and most consistent. So that's what we're going to go with. So we got to put our equations in standard form, but this first equation, the X and Y is mixed up. So you want them X, Y number. You want to go in the proper order. So we're going to switch those. And then we need to get the other in standard form. So we have to minus 3x on both sides. Look up there. And then that gives you that equation in standard form. Now why did I put an equal sign there? Why is that okay? Well, we don't care about the shading because we're just looking where the lines meet. We're not looking where the whole regions overlap. We just want to know where the lines. So regardless of whether it's a less than or a greater than, whichever side it's shaded, the lines are going to still meet at that same exact point. So now we've got them in standard form. What we're going to do is plug a matrix into our calculator. We're going to do the RREF, so find the row reduced echelon form of that matrix using that operation, and that gives us this output matrix, which really means X is -1.4 and Y is 1.8. So now we've found the only two vertices on this, -1.4, 1.8, and 2, 0. Notice, these are not vertices. Just because your graph ends here, that has nothing to do with your corners. The corners of your region are only where boundary lines intersect, and there's only two of those, this one and this one. Alright, the next video will talk about how to evaluate those and take into consideration that this part continues on to infinity.